This luckiest maths teacher in the world, thank you so much for tuning into this video in which we'll recap what we learned in week 2. So we started off by differentiating exponential and trigonometric functions. So E is this special number, 2.71828. It goes on forever. It's an irrational number. It turns out when you differentiate the function E, this number, to the power of x, you get the same function. The function is its derivative. We also learned that if you differentiate sine x, you get cos x, and if you differentiate cos x, you get minus sine x. So, to differentiate functions like this, we need these rules, but we also need to use the chain rule. So, starting with this one, the quick way to do this, using the chain rule, is we leave the e and the power alone, and we simply multiply by the derivative of the power. So, the derivative of x cubed is just 3x squared. So that's the derivative of this function done. It works like that because of the chain rule. So if I want to differentiate this function here, well, the same rule applies as before, whereby if you have something plus something else, you just differentiate term by term. So let's differentiate sine of 2x. So with trig functions, we change the sine and the cos around. So sine goes to positive cos, and we keep the thing in the brackets, but the chain rule means we need to multiply by the derivative of what's in the brackets. Derivative of 2x is 2, so I just put that there. So now I'm going to differentiate this. So I need to change the cos to a minus sign. I keep the brackets the same way they are, but I need to multiply by the derivative of what's in the brackets, in this case 2x. And just writing it a bit more neatly, I have this expression here. All right, let's now look at a worded problem. So let's do this example here. We've got a function representing the amount of money we have after t years, and we'll find how quickly it's increasing after 5 years. So hopefully this looks a bit familiar. We did an investigation to this effect. As the compounding periods become more frequently, they become more and more continuous. So you're compounding all the time. The amount of money you have is the principal times e to the power of the annual interest rate times t. So this is what you would have if you invested $20,000 at 5% per annum and it was compounded continually. So to find the rate of change of the amount with respect to time, the derivative, well, what we do, because it's a function involving e to the power of something, we start by timesing by the derivative of the power, which is 0.05, and then we leave the e and the power alone. So after 5 years, all we need to do to this formula is change t to 5. So putting that straight on our calculator, we get 1,284. That's to the nearest whole number. So it's increasing by about this amount per year. That's the rate at the instant in time where it ticks over 5 years, because remember, it's compounding continually. All right, let's now look at the product rule. So we also looked at the product rule. So that's what you use when you have a function of x multiplied by another function of x. So this formula here says when you have function of x times a function of x and you want to differentiate it, it's just derivative of the first times the second plus the first times the derivative of the second. So if I have this example here, so to do the derivative, it would be derivative of the first. So this is my first function, this is my second function. So derivative of the first is 2x, and I'm going to times that by the second plus, always plus, the first times the derivative of the second. So to do the derivative of the second, I need the chain rule. So I'm going to change the sine to a cos and keep the same thing in the brackets. But remember, when differentiating something like this, I need to times by the derivative of what's in the brackets. Well, the derivative of what's in the brackets is e to the power of x. So when you get to this line, sometimes you will need to factorize. So the only common factor here is actually x. So it'll be x outside of 2 sine e to the x. That's the first term. And then what do I times by x to get the second term? It will just be x e to the x times cos. of e to the x, okay? And then we're done. That's the final answer. All right, keep your head up. You're doing a great job. This has been the luckiest maths teacher in the world. Have a nice day.